Hello YouTube, welcome back to the garage and the little Honda CB-1. In the last video, let's just zoom out. Hello YouTube, welcome back to the garage and the little Honda CB-1. In the last video we looked at why it wouldn't start, and in the case of this particular bike it was purely down to the carbs needing a good clean out and resetting up and some fresh fuel. However, very often you can get electrical problems with these bikes. Now, there's nothing inherently wrong with the electrics on these bikes. They're actually pretty good components and fairly well designed. But of course, they are coming up to 30 years old. So in those 30 years, previous owners may have done their own little bodges, or more than likely, corrosion has crept in and you'll probably find you've got the odd dodgy connector, maybe a bit of corrosion in the actual switch gear itself. So what I'm going to do is look at some of the common problems that you can get with the electrics on these bikes and how to quickly check them and hopefully rectify them. So the first problem we're going to look at, no power at all. When you turn the ignition key on these bikes, you should get the oil warning light come on, side stand light and the neutral light. Now, it's quite common that when you do turn the ignition key, you'll end up with something like this. As you can see, none of the lights have come on. We've got no power anywhere. So the first thing to do is, as we did in the last video, check your battery, make sure you've got at least sort of 12 volts plus. If the battery's fine, then the problem is very likely to be your main fuse, and that lives on the starter solenoid. The starter solenoid is this device here, and on top of the starter solenoid is your main power connector from the battery. And inside here you will find the main fuse. It's a 30 amp fuse. So we just need to get our multimeter, put it onto the ohm setting and then touch the terminals of the main fuse. So one on each, and hopefully when you do that you should get a reading of around about 0. That means there's 0 resistance and the current is passing through the fuse. So in this case, this fuse is okay. If you find that you get a reading of 1, like this on your multimeter, it means the fuse is blown, you're going to need a new fuse. So replace the fuse if necessary, reconnect everything up, turn the ignition key, and you should have all the lights with the new fuse. However, very often when you put the new fuse in, that fuse blows instantly. And what that indicates is that you've got a major short somewhere in your circuit. And the biggest cause of that is either the solenoid itself, or more than likely it's going to be the regulator rectifier. And that lives just around the other side of the bike, just under here. So it's a unit covered in finning, and it'll have a white plug with 5 pins going into it. 3 yellows, a red and a black. And very often when the regulator rectifier fails, it causes a short, which causes those to blow. The only weak point in the electrics on these bikes is the regulator rectifier. It's way too small for what's required. The original ones don't even have cooling fins on them, so they can overheat and break down. And also the wiring that goes from the regulator rectifier back to the battery isn't as direct as it could be, so it does build up some resistance. So it's not uncommon for regulators and the regulator rectifier to fail on these bikes. In fact, it's the most common electrical component that does fail. So how do we check that it's the regulator rectifier causing the problem? Quite simply, unplug it, put another fuse in, reconnect everything, turn the ignition, and if the fuse doesn't blow whilst the regulator rectifier is disconnected, you know that's your problem. If it does blow, chances are it's the solenoid, in which case you need to get a replacement. Now, this particular starter solenoid has been used on all sorts of bikes, Hondas, Yamahas, Kawasaki's, Suzuki's, you name it. They all use basically the same solenoid. They're not expensive, you can buy them online, so just get yourself another one, replace it and see what happens. If the fuse still blows after checking the regulator rectifier and the starter solenoid, then it's very likely you've got a break in your wiring somewhere. And the most common place on CB1s for the wiring to break is up here around by the headstock, where the wires rub against the metal. So unfortunately, if that happens, there are no options but to go through all your wiring and try if you can figure out where the short circuit is. I'm afraid you're going to be really busy with the multimeter and the wiring diagram, and it is one of those jobs that you just have to persevere with. Second problem. We've checked the main fuse, we turn the ignition key, and we've now got all the lights on the dashboard that we should have. But when you come to press the starter motor, or the starter button, nothing happens. So we need to now check the starter solenoid itself. It's a good idea to actually disconnect the starter motor at this stage if you like, but we can check it as is at the moment. So the first thing we need to check are the other fuses, and there is a secondary fuse box here. Conveniently, it's located next to the starter solenoid on the CB-1. On the actual CBRs, it's located up in the front fairing, more or less behind the left-hand front indicator. So if we take the cover off, Honda very conveniently write in the fuse box what each fuse does. So in this case, it's this fuse here that controls the starter switch. So like we checked the main fuse, I'm just going to put the multimeter on ohms and just check across the terminals of the fuse to make sure that the fuse is fine. And you can see we've got 0.6, 0.5 ohms, that's fine. Also, you can physically see on the fuse, you can hopefully see the little loop in there, and you can often see that it's blown, but it's worth checking with a multimeter just to be absolutely sure. So we know in the case of this one, it's not the fuse, so we can put the fuse box back on. And we need to now check the connections that go to the actual solenoid itself. Okay, Honda have designed the CB1 and the CBR so that you can only actually start the bike when it's in neutral, or if it is in gear, if you've got the side stand up and the clutch switch pulled in. So they're doing everything to make sure that you can't actually start it in an unsafe situation. There's a really good diagram in the CB1 workshop manual that explains this part of the circuit, which looks like this. And the way that the starter motor switch works is it takes power from the main feed on the solenoid, it then travels up through the loom, and there is a black wire that feeds into the switch, and it then comes back down, and it comes back down this yellow wire with the red tracer. That then hits the solenoid, which needs to earth out through this green wire with the red tracer. And that green wire with the red tracer actually goes through the neutral switch to go to earth. And that's how it detects that you are actually in neutral before it starts. So, switch the bike, make sure the bike is in neutral. And what we're going to do is, again with the multimeter on ohms, if you put the positive or the red cable in the connector for the green and red terminal, and then touch the negative on the battery, you can see that you've got a good path, and there I'm getting all sorts of readings, but it's coming up at about 100 ohms when it chooses to show. Like everything, buy a cheap multimeter and it won't ever be as good as the real thing. So the other thing we need to check, so we know it's earthing, now we need to check whether the power is actually getting down through the starter motor switch. Unfortunately, you have to reconnect this switch, or this connector, in order to get power up to the switch. And it's not uncommon for corrosion to occur within the starter button switch or even the kill switch itself. So what we have to do is delve around in the headlight. So I'm just going to move the camera and we'll have a look inside the headlight. As you can see, Honda are very, very good at cramming a lot of wiring into a very small space inside the headlight. The connector we're looking for, conveniently, is quite near the front here. It's this red one. So if we just loosen off the retaining clips, pull that forward, and disconnect the actual connector itself. So if you have a good look at the connector, look for any obvious corrosion on the terminals, give it a squirt with some contact cleaner or WD-40, that would certainly help. And the side of the connector we want is the side with the pins in. Okay, not the side with the plugs. So we want the male pins. And the main power for the switch comes from the black wire, which is here. So I'm just going to connect the multimeter to that. And then we find our yellow and red wire, which is in the middle at the top. And when we press the starter button, you can see we get a reading of about 0.8 of an ohm in this case. So that's proof that the starter button on this works. If you don't get a reading, then you are going to have to remove the housing and again clean all the contacts inside here. It's not unusual for corrosion to build up. Whilst we're here, it's also worth connecting the it's also worth checking the kill switch, which again takes its power from the black wire, and when it's on it actually feeds it through the black and white wire. So hopefully when I touch against that, you can see again we've got less than an ohm, yeah, 0.9 of an ohm, and if I click it on, we go to open circuit, click it on, less than an ohm or an ohm, click it off, and we go to open circuit. So I know the kill switch and the starter button on this bike are working fine. And the only other thing we need to check while we're here is to make sure that there is a good connection between the red and yellow cable at this end, and then we go back round to the starter solenoid, and this time we want to check where the yellow and red cable goes into the loom. And then check it again at the connector, the solenoid, again, at 0.8 of an ohm. So I know that wire's all good. So having done all those checks, and if necessary cleaned your connections, taken the switch housing apart and cleaned all the connections there, you should now have a working starter button. We've now established that the kill switch is fine, the starter button is fine, there is power getting to the solenoid, but still you're getting nothing from your starter motor. So we need to check the solenoid. And the solenoid is basically an electromagnetic switch. So the power comes in through the yellow and red wire, energizes an electromagnet which closes a very heavy duty switch, which then allows the power to go from this terminal here, which is connected to the battery, to this terminal here, which is connected to the starter motor. When you actually press the starter button, you should be able to hear this click and the starter motor will start. Or at least it would do if I'd reconnected the connector at the front. We'll try that again. Hopefully, as well as the noise of the starter motor, you could hear that clicking. If you don't get that clicking noise, then chances are your solenoid needs replacing. If you do hear the clicking, but you still don't get power to the starter and the starter motor doesn't turn round, there is one final check you can do. But this really isn't for the faint-hearted, and it's something to be very, very careful about. We can actually very quickly bridge these two contacts. Now what you need is a screwdriver with a very, very heavily insulated handle, because there's a lot of amps going through here. So make sure your hands are well clear of the metal shaft of the screwdriver, and you only touch it by the handle. And what you want to do is put one end of the screwdriver on this terminal and very quickly just arc out the two terminals. As you can see, there's a lot of sparks, and you really just want to briefly touch it and move it just enough to turn the starter over, because you can actually weld the screwdriver to the terminal and melt the terminal. So be very careful. Hopefully by bridging them, the starter motor will start to turn. If after bridging the terminals the starter motor doesn't turn, check the cable that goes from here to the starter motor, make sure that's okay. And if that's okay, then chances are your starter motor isn't working. What you will find is, if the starter motor doesn't work after you've done that, if you actually touch the starter motor and it's hot, that's a classic sign that the starter motor isn't working. So I think that is all the tests we need to talk about to try and get it running. Hopefully with everything there done, you should be able to get the bike running. Okay, I think we've covered most of the common electrical gremlins with these bikes. So a quick recap: if you turn the ignition switch on and you get no power at all, none of the lights are illuminating on the clocks, check the main fuse that's located on the solenoid connector. If that does happen to blow when you replace it, try disconnecting the regulator rectifier, sticking another fuse in, and seeing if that works okay. If it blows again, then you've got a short circuit somewhere else, possibly the solenoid, or possibly somewhere underneath here where the loom is rubbing against the frame. So check all those. Once you've established you're getting power through everything on the bike, check the starter button. First of all, check that it's earthing out correctly through the neutral switch, and then secondly, check that it is actually sending power down through the red and yellow wire that connects to it. Obviously you may have to take the headlight off to get at the connector, and at the connector check that you're getting continuity through the starter switch and the kill switch. If necessary, you may have to dismantle the switchgear housing here, get some contact spray out, clean it with contact spray, and try again. In the worst case scenario, you may actually have to dismantle it. If you do, be careful. There's lots of small screws and some awkward little ball bearings and springs that do tend to fly off and go missing. Once you know that the starter switch is okay and it's still not turning over on the starter motor, then we can do that rather nasty, scary, sparky thing of bridging the contacts on the solenoid. If you do that, and like I said, be very careful. Don't keep the contact there for more than half a second or so. If after you're doing that you find that your starter motor is getting warm, then I'm afraid it's your starter motor that needs replacing. So they're the main things. Hopefully, after you've checked all that, you've now got a happy running bike. The only thing I haven't discussed is the fuel pump. They can fail. And really, the only way to check those is to actually put 12 volts through the connector and see if it pumps. So you may want to connect one end of the pump up to an auxiliary fuel tank, and then have a hose going into a large jug, or something like a 5-litre container or a fuel container, and see if it is actually pumping fuel through. They are another one of those things that is quite common to fail. So, thanks for watching. I hope that was all helpful, and I really ought to get back to the little CBR 400 track bike. So I'll see you in the conservatory soon. Cheers.